object encrypted. Okay, sorry. Actually, then I just added one more test case regarding to make sure that we verify SSEC headers on multi-part completion. And I see that you have, Casey, started a test run for a multi-part as well, and it seems to be failing on multi-part as well. Just wanted to ask if there's any update on that. Should we consider taking the other PR, or do we want to still wait for the other one to comply in the end?
I guess, Marcus, what do you think? Have you not had time to look at the failures? What would you prefer?
I've been fully occupied with something else, and I haven't had a chance to look at it. I guess I would like to wait and take a look at the problems I've got.
Okay. I think that we've missed the boat for Tentacle on this, unfortunately, so I have no problem with that. If Cena's PR is ready and passing tests and there was time to get it into Tentacle, then I would lean that way, but I think we can defer to a point release. Adam, does that sound reasonable?
Oh yes, very reasonable.
Cena, thank you very much for writing the test cases. If we've got a new failure in the latest test run, would you be willing to just copy the results onto the failure onto Marcus's PR so that he knows what to look at?
Absolutely, no problem.
Okay, anything else on this topic? All right, next up, Gabby. Welcome, Gabby, to discuss CLS hash.
Hi. So the CLS allows the OSD to calculate the hash without sending data to the RGW. You send CLS request and the hash type. At the moment, I'm supporting MD5, SHA-256, and Black3, but we can add many others. All hash types support doing this on a single object. If the RGW object is using a single Ceph object, then OSD is initiating the hash calculation, reading the data into local buffer, feeding it into the hash, and finalizing. The finalize returns 1636 bytes of data, and that thing is sent back to the caller. So that thing is simple, and it's very easy to support, and it's easy to see why it's useful. The problem is that it's only helping object with a single Rados object. Once you have larger object which require a manifest with multiple objects, you cannot use it because you need the state from the hash to be transferred between the OSDs, because everybody just sees part of the picture. I was unable to do that in the general case, but Black3 is different because the code is very easy to handle. So in my CLS, After calculating the first part, I'm taking the state, doing NDNS massage, and packing everything into buffer list, which is few hundred bytes of data instead of 4 megabyte. That thing is being sent back to the RGW, which routed to the next OSD. The RGW never look inside the state, it's opaque. And the next OSD opens the state, does all kind of sanity check to make sure that that's the correct one and that's the offset is in the right position, so we didn't skip anything. And if so, it continues feeding the next chunk of data, taking the state, packing it, and so on and so forth until the last one, finalizing and sending back the product, which is a 32 byte of data, and that thing is understood by the RGW. The problem is, as Casey mentioned, what we need to do in case Blake-free change the local state data structures. Blake-free state specifically that the state is private data structure, which might change in the future. In reality, version 1.0, which was released 6 years ago, is using exactly the same state that we have now in 1.8.2. I don't think it's very likely that it will change, but there is really no guarantee that the state data structures won't change in the future. So there are a few things we can do here. The first thing is Blake-free is a submodule. So we control if and when it gets updated. It should be updated because the submodel we have now is 2 years old. It could easily be updated to 182. I don't see any problem with that. But we could decide that we will not update it before making sure that the state data structure is the same. So for this, we need put static assert, and then if somebody will try to update the version, we're going to see the problem, do a quick verification, making sure that nothing changed, and if so, allow that. Otherwise, stop the update. So that's option number one. Option number two, which is also implemented, is using dynamic check. The CLS, before you load it, is verifying that the Blake-free library is still using the same data structure. It's within the supported version. And if not, it's disabled the optimization. Sorry, it's disabled the multi-part support. And if a request arrives from the RGW asking, do for me this concatenated Blake-free calculation, it's going to refuse and send not supported. In that scenario, the RGW is going to fall back to the old behavior in which the hash is calculated locally. So that's two options to handle this scenario. I got them both implemented. I'm waiting on people's feedback to see which one is better to do. Questions, suggestions, objections? That's the time.
Yeah, thanks. Right. So this design kind of treats the Blake-3 library, especially under the assumption that unlike other hash libraries, we can serialize its state over the network, right?
Correct.
But the point that its state is a private implementation detail, I think invalidates that. We can't really serialize it and handle NDNS, et cetera, without relying on private implementation details. So that's my first point.
But why not do like a best effort approach here? if they change it, which is unlikely, but can happen, then the RGW, sorry, the OSD that, so the RGW couldn't care less about the structure. It doesn't look into this. The OSD that will get the malformed structure because of a mixed cluster or anything, then we'll just reply with an error. And then the RGW will fall back to be reading the entire object and doing everything inside the RGW. It's really the client's solution to fix that. But because this is a hypothetical future problem that, and currently this implementation has huge benefits from performance perspective, then why not take the advantage of what we have now and fall back to whatever, like the same approach that we might take now in the future if the problem happens.
Right.
Yeah, so there's potential for an optimization here. If the Blake 3 library changes, that optimization turns into a pessimization where we're doing extra round trips to the OSDs.
No, not correct. Sorry, incorrect. It's going to happen only once. The first time you fail, you set a flag, and from that point on, you'd only use the whole behavior. So you go to legacy behavior, and legacy versus new approach is a one-time thing. You always start optimistic. You try this optimized version. The first time you get not supported, you raise legacy flag, and from that point on, you would only use the legacy. So if I got a billion object, I'm going to pay one extra hop. I'm not doing this per IO. It's not a per IO request. I don't start it again and again.
Sorry, I don't understand, but you don't have a global state in the RGW. How can you handle that?
Not in the RGW. At the moment, this thing is only utilized by my code. So I'm the one doing this fallback.
Yeah, no, I'm talking in general.
Well,
Any client of the CLS library will have to do that per object. I mean, not per Redis object, but per whatever object they're trying to figure on the client side, right? To calculate on the client side. Let's say if you have an object on the client side, this could be the RGW, of course, that has 100 parts, then once they fail on the first part, they'll do that for the rest of the parts, right?
Not just another part. They will do it for any future.
No, but this is specific implementation that can happen only in the dedupe code because of very specific things of the way the dedupe is working. In general, a client using the CLS will do that per work item that they're trying to work on. Because in general, we don't have global state or anything that we can count of in the RGW.
So I don't know what to say for everybody else. I know what I can say for myself. Everybody else can just don't use it if they don't trust it.
So we don't share states between IO path in the RGW. Different IO paths in the RGW are not sharing state.
You do have.
Then you have like a global variable to say that's legacy, or you could put it inside the CCT in the.
Right, exactly.
Anyway, I think this is useful even if we're talking per work item.
Per work item, Casey is right. It might be just annoying to waste this extra query and get it rejected. But really, I can add a state into the CCT, and then you could check it before if you want to use it. And by default, it's going to be enabled, and you fall back to legacy code if after the first failure.
I can see medium issues with this. For example, you have different OSDs with different versions. Some of them are supporting that, others are not supporting that. So I wouldn't go there. I would go into the assumption.
You're talking about optimization. the point where that specific edge case happens, right? Where we switch to a different library that might in the future not support that.
Yeah.
Like
Also, I mean, right.
So I'm not sure. Like, don't try to over engineer it, right? If we shut it down at that point, like we put some safeguards here now that might affect the performance in maybe some minor way. Don't stop the development because of that. Maybe we can find some other ways to do it, but I wouldn't bother with it right now.
I think we should have this concept of first do no harm, meaning I think this optimization is valid and is very likely to benefit us, but in the unlikely scenario in which future Black library may be starting to use GPU instead of the AVX, and they're going to need some new data structures, I don't know, it might happen. And then I would look at this. So there's two scenarios. One of them I'm saying, okay, they change it, but I can support it with an enhanced version. So that's the good case scenario. But it might be that they would start using dynamic allocation and such, which going to be, or they're going to use complicated state, which I don't understand. Again, unlikely, because the Black free code is textbooks style code. You read it and you understand everything. I don't even need to read the documentation to see what they're doing, because everything is very straightforward. But they might change it and use cryptic code, which I don't understand. In that scenario, I'm going to disable the optimization, and probably the new code, if I'm seeing this, I should be able to go and disable this inside the code. But just in case I forgot it, it should be handled automatically by the code and disable. And then once you fail to get it, probably it means that OSD has been updated to newer version. You should stop trying. In that case, fall back to legacy, and that should be across the board. Don't retry it.
Yeah, I agree. Also, I mean, I really agree with you that we shouldn't try to kind of overcomplicate that for something that may or may not happen in the future. So it's a great improvement for the current performance of the code. I don't see an issue why not adding this.
So you suggest static assert on changes, or use a dynamic? Because static assert is very simple, but even the dynamic, it's not really so much code. If you look at the changes between the two versions.
Hold on, static assert won't help you in a mixed cluster, right? Because
no, static assert would means that you would disable, sorry, you would forbid going to newer version of Black, because Black is a submodel, Black free is a submodel. Static assert means I don't want you to update.
You can add, hold on. You can add a static assert, but if somebody wants to upgrade to a new Blake version and they have strong reason for doing that, they'll just delete your static assort and fix the problem somehow, right?
They will set a static assert which is going to be coded. If you do these things, you want to remove it, then just there's going to be a flag saying disable optimization. End of story.
No, but I mean, in this case, you would also must write code to dynamically handle the situation, because static assert or removing of code or changing of code can help you only with code that is new. Existing code you cannot do anything with, so you would need both.
I don't get it. So at the moment I have both options in my system. So static assert, it means it's a submodule. We don't allow anybody to upgrade the submodule beyond a known position.
So a submodule. One second. A submodule is pinned.
Put a very clear message. If you want to upgrade above that point, then this flag should be set to false.
So a submodule is pinned to a specific version. This is what a submodule does. You can add static assert. This is fine. If somebody wants to upgrade the submodule, they would upgrade, and they have good reason for doing that. They would upgrade the submodule, and if the static assert break, they will go and fix it somehow, or I don't know, do something with
But I
it,
mean,
change your
fixing
code
somehow
anyway.
should be set this flag to false.
And
I have to say I don't think that I think that well, I don't know if this is the right answer or not, but I don't think that we can I don't think that we have to assume that users will remove a static assert while precisely fixing a compile error that warns them that they can't do this because reason. Anybody if that scenario actually arose, I'm doubting it. If that situation actually arose, anybody who upgraded the Blake submodule and then patched the code to permit it to compile would also observe the static assert is telling him, don't do this because X.
Yeah, and I can make it very simple. I don't instead of saying don't, I can say static assert, and it's going to be a clear message. If you really need a higher version, then you must set this flag to false.
Or you must figure out that it still would work, right? That I think is the more important piece.
Yeah, it's not really a matter of setting a specific flag. They will have to fix the issue. Otherwise, also regression tests should fail and so on and so forth. But
no, sorry. The regression tests are working fine when the stuff is disabled. I'm running my test, and the test support this mode. When the OSD reply back say not supported version, I'm falling back, and all the test knows how to handle this. I've been running the test, and they run fine. My test for this.
Yeah. So what I'm saying, they will have to somehow figure out the problem. I mean, you should put a static assert. You should have it's not necessarily that they're going to set the flag. They'll have to fix the issue. It depends what the change is going to be. It depends on things that we cannot envision right now, right? So you cannot tell them what is the fix because we cannot know that upfront. So
I would like them to come to me or to you or somebody here and show us the problem, because I can take a very quick look. If the data structure wasn't changed, then it's fine, because maybe in 195 they're going to be great optimization, but it's very unlikely that the data structures will change. So I would say, sure, just go for it. I'm just going to change the static assert. Instead of saying 182, I would say 195, and that's fine. That's the most likely scenario. But if we're going to find that 195 is going to use crazy new state, I don't understand it, but the optimization is worthwhile, then yeah, okay, I can disable the CLS enhancement. That's...
Yeah, but you would need the dynamic check anyways, right? Because
yes, the dynamic check exists in both scenarios.
Right. So I don't see this as a problem or an issue. I mean, they may change or not change the static assert. They may change the code or not. If they're going to have a mixed cluster with, let's say, OSDs with more than one version, then they might get the failure and then be like an extra.
I don't care about them having multiple versions. It's okay to have one OSD running 1.5, the other one 1.6, and the last one doing 182. That's fine. The problem is only if the new version is higher than anything I met and qualified.
So what I'm saying is that they can have OSDs with multiple versions. If for some reason the types are mismatching, then the OSD is going to complain. One of them is going to complain about the state being incorrect, and the RGW will just have to, or the client of the CLS will just have to handle that. So, and again, this is all hypothetical. It may happen, may not happen in the future.
Yeah, so I can do the dynamic option. Maybe I should also add, I don't know if there's like a static assert, but maybe I can add a static warn. So if new version comes along, I shouldn't automatically fall back. I should just do a quick check, and I might add a patch, a one-line patch. Okay, that the new version is fine. Keep using it.
Again,
but in
I don't think anything like that.
Version, the dynamic version which I tested is working. It's very simple. If I'm not familiar with the library. It looks different. I'm falling back, and I'm only accepting black 3, like SHA, like MD5, for a single part object. If you have multi-part, it's going to be rejected. The client going to see it and set legacy behavior. And from that point on, they will not use the CLS. They will only use the CLS for single part object. Single part object always can do the CLS. There is no reason to disable it.
Is there like a unit test that uses like an IV, like a static interrupt, binary data or example or vector that would let you prove that when you're building the software that it's still going to work?
Yeah. So my unit test, I ran my unit test with changing the library. But for this, I need to hack the code. It's kind of ugly, because for the unit test to happen, I need to change the OSD.
Well, I mean, couldn't you? I mean, it might be possible to construct a workflow in a G test that does the steps that would be to externalize the and then recompute and see if it matches.
So for now, what I did internally in my system, I changed the string, so this thing failed, and then the whole thing was able. I got like a few hundred of tests, all of them completed successfully, even after I faked that the library version is now not supported. I changed the library string in black 3. Again, it's something you can only do for testing, but I don't know how to make it then.
I mean, what we're saying though is we're no longer. The scenarios are ones where we can still compile this code, but if we interchanged data to later combine the checksums, we'd get the wrong result.
No, you won't get the wrong result. It will just abort the operation, and you would start it using the legacy behavior.
No, I understand. I understand that's what you've coded, but I'm saying that I'm asking about the original scenario, where the code still compiles, but when sent over the wire and reassembled, it no longer produces a valid Blake 3 checksum.
Oh, so I have some unit tests in which I'm changing the data structure internally and making sure that it's being captured on the other side. There are some sanity checks I put because I understand some of the data structures. So for example, in every data set, there is always, they have the offset. So whenever you are, the state always encode inside the current position. So by just skipping one, so let's say I got 5 units, I'm skipping, I do like first, second, then fourth and fifth. This thing is going to be captured and rejected as illegal. So this kind of stuff. Matt, did you hear me?
Yeah. I guess I'm answering my own question. If there's a way to construct a sort of static unit test that would indicate that some unknown change that's in the library while still compiling would be reliably is still valid. I'm guessing we can't do that trivially.
I'm not sure how to dynamically change the library name.
No, I'm not talking. Never mind. I wasn't trying to say that at all. I'm talking about the change in the wire format that you actually care about. The change in the internal structure that you would have to compensate for to fix the issue.
For now, I don't compensate.
For it to become incorrect.
For now, it's a binary state. If the library is using exactly the same structures that I know, then I'm using it. Otherwise, I'm not using it. I'm not
Yeah, I
going to
understand
have two versions running. I mean, we could have in theory, but I don't see a reason for now.
I mean, what would be interesting is if, well, is if the library implementation we're using had version data structures, and maybe that's not totally crazy to discuss with them.
So I can try and reach them and ask them if they can commit, or maybe if they can provide serialized API. In
That would be
theory,
interesting too. Yeah.
I mean, I see no reason for them not to give it, because if 6 years they manage to stick with this thing, maybe they can give a serialized API. And maybe the serialized would have like a version encoded, then you know which version you have. Because if they change version, they can just change the serialized. It is possible for them to do that. Like, I would say very easy to do that. It's really like 1 hour of coding, but of course, it's their code. I can only ask. I don't know if they're going to react.
Yeah. Well, that's an interesting. It's an interesting suggestion, though. We might be able to offer the code itself and see what they do with it.
But I mean, if the serialization changes between library versions, I don't think that helps us.
Yeah, we'll go to this. We'll fall back to the same. I think that there are two different issues here. One is the issue is, can we statically detect that something changed with the library? And there's another issue, which is what is the runtime behavior, because this is completely unrelated. We have to support detection of runtime wired changes. And but anyways, if we support the runtime thing, then again, I don't see any reason why not adding this.
So my objections are mostly just on general principles, that we shouldn't rely on private details of libraries, and we shouldn't make design choices that could force us to pin a dependency version. Sometimes there are special cases where that really is compelling, but is full object dedupe one of those? Is it worth it? I mean, we're talking about falling back to the default behavior and being okay with that. So I would argue that it's probably not that compelling.
But again, you don't pin, so you have two options. If you pin, then you don't need anything. If you don't pin, then you have the fallback. The current implementation, the last version, with the fallback allows you to keep updating Black 3 to whatever versions you have. And if something happened, then dedupe would fall back to legacy behavior. That's all.
So, Casey, the scenario in which we're going to have the issue is if we have a mixed cluster of OSDs, right? That's the only case where we actually have an issue, because this is not something like the state that we're saving is not saved on disk for long term or something. So the problem happens only if we have a mixed cluster of OSDs, and that's going to happen only during upgrades, right?
Yuval, it's more than that. It might be that a newer version of Black is something that I cannot handle. They might change it in the future and create a version.
This is fine, but what I'm saying is that if they're going to change something, we're going to adjust the code to match whatever they change. If because of what they change,
possible, but it might be.
Hold on. If because of what they change, we cannot do this optimization, then we're going to cancel it. If they're going to change something that allows us to do a different kind of optimization, we're going to go for that. What I'm saying is, the problem of the extra unnecessary hop is happening only in the case of a mixed cluster of OSDs.
No. It
Yes.
happens if
Not necessarily, no. It could also be because the components can no longer be combined by the logic that we've upgraded to.
But in this case, it's not an extra hop. So what I'm saying, let's say that they change the structure to something that cannot be combined. In this case, we're just going to fall back to what we have right now.
Yes,
Yes.
that much is true.
So
But the-
Casey's concern with the extra hop is only for a mixed cluster of versions of OSDs.
Yuval, the extra hop is a one-time penalty. If I got
No,
1 billion
no.
object, I'm going to pay this extra hop one time. That's nothing.
No, that I
I'm
disagree.
not going to pay per object.
I disagree with this. It's not gonna be a one time because of the way that we're doing. Like in dedupe, it's gonna be a one time, but not generally.
Why
But-
not? Put it inside the CCT as a state, as a global
Because
RGW state.
RGW is a stateless creature. It doesn't.
But the
stay
CCT
state.
No,
has
you-
state.
I wouldn't agree with that. I mean, there's
But
no
this
reason
is-
why
this-
we couldn't do that.
Okay, but this is a different discussion. What I'm saying is because this is only for the time of upgrades of OSDs, then I don't see why this is an issue at all.
Yuval, you're not correct here. Because if OST has been upgraded to a newer version, which doesn't support, that we cannot support, then every future request for the CLS would have the same failure. It's
No,
not going to be a
because if we're upgrading to something that doesn't support that, we're going to change the code and remove this optimization altogether.
assuming that that everything was done in organized way. But if somebody upgrade once just a black submodule without changing the code, it could happen. I don't know, if somebody just
check.
removes stuff and put it, then you need some way to protect against it.
So why we don't make it so that if Blake does not support it and we cannot get it to work in a way, like sometimes hypothetically in the future we pin the previous Blake version or do stuff other solutions, right? We don't allow the Blake to be updated to the newer version, or if someone does it and it's not compiling, then it's really their problem, but we should be able to keep using the feature as it is now. It's I'm not sure why we're even discussing it.
Well, maybe the one reason would be if some upgrade if some upgrade is forced by, I don't know, a security reason. I don't know if that's realistic.
So they should fix the code. We should break compilation on that, and they should fix the code. And if the fix is to remove this entire optimization, okay, so be it.
Right, but the whole discussion is really like I already know what the color of the bike shed is, and
What color is it?
Second bike, it's metallic pink.
Okay, so my take is that I think we should all move to Blake 3, start using this globally. And my goal is, if dedupe is running, to eventually have all the objects in the system with Blake 3 hash encoded in them, in addition to MD5. That would allow clients to get a stronger hash than the MD5. But that's a side thing. And so Blake is order of magnitude faster than SHA. That's not question. Can we use it with the CLS? I think the CLS is important because it reduces the load on the messenger. And OSD messenger is the bottleneck. Eventually, when you read the amount of how much the OSD can service, it's always how much, I mean, there's a limit, but for now, the limiting factor is messenger. You cannot do more than the messenger can do, and this thing reduce very big amount of what the messenger does. So it's a good thing to do. At the moment, I'm the only one using Blake 3. So in theory, I could pin it and say, that's for me.
Well, that's not true.
Who else is using it?
Well, who put it in the code base?
I think you.
Yeah. But anyway, but I don't disagree with the basic idea there. I think we do want Blake 3, and I think we probably want to expose it in the additional checksum interfaces, which I haven't done yet, but you can see that it's plugged in there.
Yeah.
I mean, I don't know about the CLS piece completely, but I don't hate it. I think we could also consider adding that as a second step, if we can address some of Casey's issues.
So yeah, I mean, I'm just arguing on principle. You're the one that added the submodule. If you're okay with pinning it somewhere forever,
I don't think we'll have to actually have to do it, but I think it's not going to cause a lot of disruption personally. I think we should look at some other things. We could talk to the maintainers, look a little bit at whether other people have thought of this type of offload and see if there's maybe a way to make it more robust for it.
I would expect that people did distributed Black free. We couldn't be the first one doing that.
We probably aren't the first to have thought of it, including the inventors. So I think we should maybe pursue that if we're interested in going this way. But I don't strongly object, Casey. I mean, I think this is an optimization that we get that, and I think the defensive stuff that Gary's doing is safe.
And as Yuval mentioned, if we put static assert and you decide that you need a new version, that's fine. We can look at it. If it's using the same data structures, great. Just update the static assert. If they change the data structures, but we can still understand it, we can create a modified code. If the new data structure is complicated, we don't want to do it, then we just disable the optimization in the code and fine. Because the code does have the legacy behavior. So instead of alternating between them, we can just say just the legacy behavior. And at least in my code, this thing is done dynamically. Because once you fail, from that point on, you would only do the legacy behavior. I think it should be possible to do it with RGW if we put the legacy flag inside the CCT, which means maybe, I don't know, the CCT might change from time to time, but you'd pay this extra hop once in a blue moon, no big deal. So I think all of these behaviors should be fine. So we can combine all of them.
I guess I would vote in favor.
You'd go to what, sorry?
I would vote in favor.
Yes.
But I also agree with you, Huda. We've burned a lot of cycles on it.
And it's something that if it was possible to do it for MD5, I would do it, but it's just too complicated unless the objects are small. Do we ever calculate MD5 from the RGW, or it's always inline?
We calculate MD5s and RGW, but let's not even talk about calculating MD5s.
But I'm saying it's just an inline when we have the data anyway. We never read the data to verify the MD5.
Not that I'm aware of, no.
Okay.
So Matt, don't hate me, but recently you discovered that CRC can do these composite checksums naturally, like out of the box. Maybe we do part CRCs and combine them in a way that makes sense.
Well, isn't a stupid thing to say. I think we might want to use the combining API to combine Blake 3 checksums, but the CRC 64 is not an alternate for Blake 3. Blake 3 is a cryptographically strong checksum. I don't even know what the CRC can't even be used for this purpose, even though Amazon seems to be pretending that they can.
I mean, even MD5 that they use we know that it can be broken. One of my tests is generating identical MD5 for different objects to make sure that I can.
So what's important about Blake 3 here, as opposed to like XX3, which I also chucked in there, it's cryptographically strong.
Yeah,
that's why
Blake
it's
3 is probably the strongest known now. It's comparable to SHA-256 or SHA-3 maybe even. So
I mean, why not just do per object Blake 3 checksums and then sum of checksums for a composite that we do for object comparisons?
Well, we could do that, but that would be more complicated for. Well, we could do that, and that would be Amazon. You mean Amazon compatible like composite checksums, right? Like the composite digest.
Oh, you mean the way they combine the MD5?
I think that's exactly. You can do that.
Right.
You can do that. They
Or
do that with
multi-part.
the other checksums as well.
Yeah, but
They have
it's
the
not
same idea.
wrong.
But I mean, if we were to do that, that would require the users to generate that digest. But it's not.
No,
You know,
we're talking about full object dedupe where the comparisons are just internal, right?
I don't think that's where Gabi is going for the full boat. Eventually, they could do it for anything. Users could use it for anything they want.
Yes. And once I calculated the black free for the object, I'm adding this as an attribute to the object, like the etag. So it's going to be another attribute, black free.
Yeah, I think that's really elegant, and I think that gives us something.
So the next time if we do an incremental dedupe, in my case, I don't need to read the data again. But for others, it means you could do a stronger comparison, sanity checks, and others.
You could use the digest, the composite digest for that. They're just weird and opaque.
The compass, I don't know that it's as safe. Nobody understands like I never seen any cryptographic analysis of it.
I suspect it's better than you think, but it would take sophisticated, more sophisticated. I certainly can't do it.
That's
I'm not sure.
I
agreed.
My math skills are not like.
I think you can probably trust it, but it's not the same thing. I mean, the ability to have the sequence to digest is valuable.
Because like with this thing, we have one thing, even for multiparts. So now, multiparts, the ND5 is not really strong. But with this thing, it means multiparts are going to have one strong value representing them.
I mean, the main advantage is that is the value that the end user could get examining their object without trouble.
Yes.
Is it worth investigating the security considerations of composite checksums here, or are we just going to go with the CLS version?
I tried looking in the composites, and I even try discussing it with a few of the PhD students that we have, PhD employees that we have in the office. Nobody was able to give me a concrete answer why this thing is strong enough. Everybody said it seems like it's kinda, but I think for the math you need somebody which did his PhD in cryptographic and not somebody which did generic PhD in physics or math to understand it. Or maybe they need more time to spend and more than 1 hour. That's like all I could get from them. I tried looking for math explaining why composite MD5 is trustworthy and how much do I lose by using it. Amazon just say that seems like a good idea, but they don't explain why. And definitely you lose something. Otherwise,
I haven't seen any description of the reduction and how significant it is.
But we understand that you lose stuff because otherwise you could do absolute parallel data, but you cannot do that. I mean, black tree is a parallel by design, but everything else, if you could do these composite things, then everybody could do parallel calculations. Just chunk the data, get whatever you have, and then combine them. That's definitely not the case. So black tree is maybe the only case in which you could do that because of the Merkle tree base for the design. But even there is some state that you need, and that's the state I'm transferring. It's not just the last. The last product is more than 32 bytes. And with dedupe, I'm removing data. And for doing that, I need something which is bulletproof. I really worry to use something which looks like it's safe, but we might find in the future that in some scenarios, very similar data, but different might yield the same outcome. And then I removed user data, but it's not the same data. That's going to be disastrous. And of course, that's going to happen 1 in 5 billions. So we only see it once we remove the most critical data from the nuclear reactor, and now the whole world is going somewhere. Black3 and SHA-256 are considered good enough. So I'm trusting them, but I don't know that I can trust anybody else.
But the other alternative, but the option is to not do the offload, Casey. We want to.
Yeah, I mean, we can always do this. Don't concatenate state. Just read all the data and calculate it locally. That's a safe thing. I think that the Black3 that we use now, I'm just moving exactly the state that it's using. If you look at the code, the data structures are very openly written. There is nothing else. You just have an array and few counters and you move it. So it's just the data. There's no magic there, which is a good thing. I hate magic in code.
Well, are we reaching any kind of a stable point in this discussion? What's the end state?
Yeah, I've just voiced my general objections, but I will gladly defer to you, Matt, to decide on Blake3 related matters.
Does anyone else have objection? I mean, Marcus, what do you think? You're knowledgeable about. Anyone? I think Yehuda, what was your vote? Is your vote in favor? Plus, wish we hadn't bike shedded.
Yeah, I'm in favor.
Okay, I mean, I don't feel like I'm overriding Casey, but I mean, I think the vote would be in favor.
All right, great. Thanks, Gabby.
Thanks. I will try to reach out to Black people and see if they can provide an official serialize, which then will take
Yeah, I think that would be elegant.
responsibility from us.
I mean, I think the areas they're going for suggest that would, and the work they're already doing, or others are doing with it, would make that give it utility.
Yeah. So I did a quick check, and there is something coming about 2 systems which have been using distributed Black calculation. I'm trying to find if they explain how they do that.
Cool. Yeah, if we can accomplish this, then we can up level things to make exclusive use of it.
Yeah.
All right, running short on time. The last topic was mine, but it was mainly just to advertise a feature that I pushed yesterday. S3 object ownership can disable object ACLs if anybody's interested in reviewing or playing with it. There's a link in the agenda. Any final thoughts for today? All right. Thanks,
So
everyone.
just, sorry, what is the verdict? Can we pin the version, static assert, dynamic check, or all of them?
I think we said we have to have dynamic checks. Regarding the static asserts, I'll do a bit of investigation to see if there's something more intelligent to do than just check the version number. If there's a statically way to use some C++23 magic to check the structs and do a static assert of that instead of the number.
Okay, and I found that Alpium is some kind of mining, I don't know, probably like some kind of a Bitcoin thing. They're using serialized block header, but they don't explain how this thing is done. I think they just take the C header and do endianance, and that's all, because it is a struct. But yeah.
Yeah, I'll stop for another meeting. Thank you, guys.
Thanks.
Right.
Thank you, everyone.